this video, we will be discussing analyzing and interpreting data. We'll be focusing on measures of variability. By the end of this video, you will be able to calculate the interquartile range and mean absolute deviation of a data set. So measure of variability is a way of describing how spread out the data is. It can also be described as how much the data deviates from the center. So first, let's take a look at interquartile range. The interquartile range, or otherwise known as IQR, is a measure of variability that splits the data into 4 equal-sized quartiles. It represents the box in the box and whiskers plot, or the middle 50% of the data. So to find the interquartile range, or the IQR, we're going to order the data from least to greatest. We're going to find the median, and finding the median of the upper and lower quartiles. And then we are going to subtract quartile 3 minus quartile 1 to find the IQR. A little bit more about the interquartile range is how the IQR relates to the spread of the data. So the higher the IQR, the more spread out the data is from the center. So it has greater variability. The lower the IQR means that the less spread out from the center the data is, and the less variability that there is. The interquartile range is also useful in identifying outliers in our data. So let's kind of put this to work here. So I have my data set. So the first thing that I need to do is I need to order it from least to greatest. The second step is that I need to find the median. So again, when I do that, I'm counting in from the outside into the center. So I have here, check that one off and this one, and I just keep going back and forth until I get to that middle number. And in this case, it looks like my middle number is 11. So my median equals 11. Now to find quartiles 1 and quartile 3, remember that quartile 1 is the median of my lower half of data. So again, I'm going to cross off until I find the middle there. And it looks like I'm stuck with these two numbers of 9, but what is it between 9 and 9? Well, that's 9. So quartile 1 is equal to 9. And then I'll go to the other side of my median, and I'm going to do the same thing to find my quartile 3. So I'll check off and figure out what my median is here. So again, I've got two 15s in the middle. So what's between 15 and 15? Well, that's 15. So quartile 3 is 15. Step 4 was to take my quartile 3 and subtract it from my quartile 1, or excuse me, take my quartile 1 and subtract it from my quartile 3. So I'm going to take 15 minus 9, and that gets me a total of 6. And so my interquartile range for this data is 6. Let's use a box and whisker plot to find that interquartile range as well. So now I don't have my specific numbers, but I can look at my graph here, or my plot, and quartile 1 is the beginning of the box. So quartile 1 is here, and quartile 3 is always at the other end of the box. And so this is quartile 3 here. And so I am just finding the size of my box here, which is the interquartile range. And so I'm going to take 12 minus 2, which is going to give me 10. So my inner quartile range is 10 for this data set. Now, let's take a look at the mean absolute deviation. The mean absolute deviation, or the MAD for short, measures the spread of the data in relation to the mean. So the inner quartile range was in relationship to the median. Mean absolute deviation measures in relationship to the mean. Let's take a look at how to calculate the mean absolute deviation. So first of all, we need to calculate the mean of our data set. And again, that was by adding up all of the numbers and then dividing by how many numbers we added up. And then we're going to find the difference between each piece of data and the mean. And we're going to do that to see how far each piece of the data deviates from the mean. And then we're going to take the absolute value of each deviation or each difference. And again, that's how far each piece it deviates from the mean, is measuring the distance. And remember, distance is always positive. And then we're going to calculate the mean of those deviations or those distances. And again, just like the inner quartile range, the higher the mean absolute deviation is, the more spread out from the center of the data is, which means greater variability. The lower the mean absolute deviation means the less spread out from the center of the data is, and that represents less variability. So let's take a look at this data set and figure out what our mean absolute deviation is. So the first thing that we need to do is we need to figure out our mean. So I'm going to add 3 plus 2 plus 4 plus 2 plus 5 plus 3 plus 2. And then I'm going to divide by 7. And when I do that, I get a mean of 3. So now I'm going to go through and I'm going to see how far each of my data set is from the mean. So if my mean is 3, and I look here at this 3, well, that's a deviation of 0. They're the same number. There's no distance between 3 and 3. The next one is 2. Well, my distance from 2 to 3 is 1. And then 4, distance again is 1. From 2 is 1. From 5, 3 to 5 is 2 spaces. 3 and 3 is 0. And again, 2 and 3 is a distance of 1. So when I add up all of those, so I take 1 plus 1 plus 1 plus 2 plus 1, and the 0 is also included there, but they don't change that value, I come up with 6. The mean absolute deviation, well, I take my 6 and I divide it by 7 because I added up 7 total numbers. Those zeros do count in that. And I come up with an answer of 86 hundredths. And then does the mean absolute deviation represent a large or small amount of variability, and why? Well, it represents a very small amount of variability. Because on average, each data point has a distance of 86 hundredths spots away from the mean. And that is very close to 0, which is no variability. Let's take a look at this data set. So again, first thing I need to do is find my mean. And when I do that, I add up all of my numbers and divide by 6, and I come up with 20. What is the total absolute deviation? And so when I look at here, 20 and 15, that's a difference of 5. 20 and 24, that's a difference of 4. 20 and 12, that's a difference of 8. 20 and 32 is a difference of 12. 20 and 18, that is a difference of 2. And 20 and 19, that is a difference of 1. And so when I add up all of those together, I get a total of 32. And then when I take my 32 and I divide it by 6, I come up with 5.3 repeating. And again, does the mean absolute deviation represent a large or small amount of variable, and why? Well, it represents a small amount of variability because on average, each data point has a distance of 5 away from the mean, and that is somewhat close to 0, which again has no variability.